Hello, everyone, and welcome to this.
Recording in progress.
Okay, recording in progress. No worries. So, hello, everyone. Welcome to this meetup, BcnRust meetup. We will have two talks today. The first one will be in English. The second one will be in Spanish. We will have a presentation by Cameron and Mattsi, who are going to introduce us. Well, they are going to speak about how to leverage Rust to improve our programming fundamentals, which I think is going to be very interesting. And later we will have Dayana Rodrigues, who will talk us about writing Solana smart contracts with Anchor and Rust. So without further ado, I'm going to leave you with Cameron, and that's it.
Great, thanks very much. Hi, my name's Cameron. I'm joined by my friend and colleague Mattsi from Codurance, and today we're here to present to you a presentation about Rust, how we believe you can use Rust to improve your programming fundamentals, which we've decided to name from good to great. Well, we'll explain why that choice is made during the presentation. So if anyone has any questions throughout the presentation, some people like to save them till the end. Some people like to ask them as we go along. Please feel free to ask a question or make a comment or observation whenever you like during the presentation. I personally prefer it when I receive a question when the relevant slide is still on screen, because we have the context there to help us further discuss the point that's being made. So please feel free to put a message in the chat, and either Mattsi or myself will see it, hopefully, and we can address it as they come along. So without further ado, we'll make a start. Well, we will make a start, but first, a word from our company, just to talk about who we are, who is Codurance. We are a consultancy. So essentially what we do is we go into companies that find that they're struggling with certain pain points with their development teams or with their delivery strategies, whatever it might be. And what we do is we go in and we help teams achieve the goals that they're looking to achieve. We've got a very international team. We've built our teams, which are pretty much entirely remote across several different countries and cultures. We've got offices in the UK, Spain, and Portugal, but as I say, the vast majority of our teams work remotely. There's lots of pushing for diversity and inclusion in our hiring practices. We have a huge focus on learning and development, which ties very nicely with the topic for today. So we put a great focus on continuous improvement, both for ourselves and for the clients that we work with, the other people we work with, trying to stay on top on the best practices and new technologies and things like that. We are passionate about quality, so what we talk about internally and with our clients is we try to build everything based on a foundation of code maintainability, extensibility, and readability. Sometimes we have got pulled in to optimize things and make things more performant as well. So that's what our day-to-day life is really all about. Just a little side note about Rust internally. We have got quite a bit of interest through in some sort of sub-communities within Codurance. So we've just got some fun statistics here about Rust has been mentioned over 2,000 times in our internal Slack. So that's our own sort of driven community internally, where we sort of share information and learn from each other. Of course, Rust is known for its sharp learning curve, steep learning curve. So we really do help each other learning all sorts of technologies, and we move that into our clients' work teams as well. We try to foster that attitude wherever we go. So with the plugging of Codurance there, we'll move on to the agenda for the show. So we'll start off explaining who this is for. We'll probably get the gist very quickly what kind of developer this is for when we go into that. The introduction, just laying down the premise of what it is that we want to put across here. And then we'll go into some Rust specific things. First of all, we've got the concept of borrowing, compiler errors, a little topic here called a mind for design, which we'll hopefully explain better when we get to that. And then at the end, if there are any further questions that people didn't have time to mention at the time, then we can address those as well. Okay, so we'll go ahead there. So who is this for? This is for devs who are considering learning Rust, or maybe who have just started learning Rust. Devs who haven't had the experience with lower level computer science concepts, but are looking for a way to learn, maybe a fun way to learn or an engaging way to learn. As we know, Rust has got a lot of hype behind it, so it's got a lot of fanfare. It's quite well known. I've just seen someone said they can't hear anything in the chat. I don't know if anyone else is having a problem with that, but hopefully not. Well, I'll keep going, and hopefully, if that seems to be a common problem, then we'll try to deal with that as best as we can. So yes, so it's for people who are looking to learn computer science concepts, and a way to do that in a fun way. And also, this could be applicable to people who are team lead or in management who are interested in upskilling their team members some way. And if we look here, we've got sound does appear to work. Thanks very much for confirming that. So yes, so with that said, that's who the presentation is aimed at. So we'll see. Let's get into it. What do we mean when we say from good to great? Why do we choose that as the title? And we'll explain what we mean here. So we are looking at sort of typical web development here. And if we look at what is required to be a typical web developer this day, you might get some back end, some front end, some extra languages, some older languages, some frameworks, some tooling, databases, principles, paradigms, TDD. There's so many things. There's cloud to deal with as well. So there's a huge amount of knowledge already that it can seem very intimidating to someone who wants to stay on top of things within the web dev space. And so really, it's no surprise that we're happy with that abstraction because we've already got so much on our plate as web developers to stay on top of, especially if you're in a position like we are in at Codurance, where we are sort of technology agnostic. We have to change technologies an awful lot of the time, introducing new technologies to existing clients, or maybe getting a new client, changing client. Sometimes the technologies can change quite drastically. Typed languages, dynamic languages, SQL, NoSQL, Azure, or AWS, or just straight up, the old-fashioned monoliths in an FTP server somewhere. There's all kinds of things we have to worry about, all sorts of things we have to be aware of. And so life is hard enough, really, in that sense. And so it's no wonder that we're happy with those abstractions when the larger part, well, beneath the surface, let's say, there's more technical concepts that we don't normally have to worry about because they are abstracted from us through, fortunately, let's say. They are so often abstracted away from us and dealt for us in the background by these tools that we don't often have to think about them. But what does this mean and how is it relevant to what we're saying today? Well, a modern day web developer can survive and on top of surviving, have a really great, successful career without really having to worry about these in-depth without having these understandings of these concepts down to a particularly deep level. So in a sense, it's not often that necessary to know these things. However, there are still tasks or problems that can arise within the web dev space that require some understanding of these concepts to solve efficiently. So I'm reminded of that line from that movie where it's like, works 80% of the time, works all the time. It's kind of a bit like that. It seems like it's all you need until you actually need something else. Anyone who's had a Git expert in their team, especially as a junior, might understand this feeling. I think this is a good analogy to make because if you think about how we use version control, normally, as long as you can push, you can pull, you can add, you can commit, you can change branches. That's for a lot of people, that's where we stop because you can be a very effective member of your team just knowing those things. But I think everyone's got a story from maybe from when they entered the workplace as a junior, or maybe still it occasionally happens later on. You make some kind of terrible mistake with Git and you accidentally somehow lose your branch with all these hours of work you've put into it, and you have no idea how to get this work back, and it seems like the end of the world, and it seems like this work that you've spent so much time, so much effort into has gone forever. And then all of a sudden you just speak to someone who knows a lot more about Git and understands how Git works under the surface, and they come along and they type a few commands in, and suddenly, like some magic, like some miracle, you have all your work back. And so I think that's a good analogy for explaining the kind of benefits that we can see from looking deeper under the hood when it comes to, well, computer science in general, looking at memory management, etc. So a quick example of the kind of problem or kind of bug that could be entered into a system by someone who maybe hasn't got a very good grasp on certain concepts here. You can see here within our main process, we've got a number. The person in question has has said double number, and they expect the number to be doubled. Now, if anyone in the chat would like to suggest why this doesn't work, feel free, or give a few moments to see if anyone wants to give that a go. I can see Chris Drifter said good old reflogs. Yes, reflogs are exactly what I was thinking. Yeah, that's the kind of Git stuff that yeah, only certain members of the team seem to know. There is a bit of delay, so I'm not sure how much time to leave for this question, but I will go ahead and just continue in a moment. Looks like we'll give it a few more moments. We'll give that time. Otherwise, this is going to be a very long, awkward silence. So I'm sure the answers will start rolling in on the chat anyway. But so essentially, we're talking about values versus references here. As I'm sure a lot of people in the chat will be able to see, the number that gets put in the local scope function. Yep. Yeah. So here come the answers. Of course, predictably, the delay sort of ruined the number we copied. Exactly. Yep. So the number in question is being copied into double number. So the number that gets doubled actually has nothing to do with the number that is saved here as number, as the variable number. So yeah, quite right in the chat. That is exactly what's wrong. Someone who doesn't really have that much of a grip of values versus references very well may miss that. It's a bit of an entry-level problem, really, but that's just an example of the kind of thing that can be overlooked simply because it's not explicitly stated in the code when you look at it. So that's something that you can imagine happening there. And there are lots of other things that you might miss out on if you don't have this information. Memory leaks or fragmentation, concurrency control, or really a deeper understanding of concurrency, performance profiling, security, and a whole bunch more. Security, of course, being a big one for Rust with the it being known for being safe. I'm sure we've all heard about the White House in particular talking about wanting to port things to Rust for the safety reasons. I think Linux has started to bring Rust in there. Windows has started to do it, and the list goes on for that safety. So what has this got to do with what we're talking about today when we talk about learning Rust for these benefits? So what the idea is that we're positing today is due to certain characteristics of the language, Rust is an ideal tool for helping developers understand these previously unfamiliar lower level concepts, and in other words, leveling up. So sort of making yourself better in general as a developer, thanks to learning these concepts through Rust. Now, as we said at the beginning, this is not just for people who want to use Rust professionally either. So the thing that makes this talk interesting, I think, is you can just learn these concepts through Rust. And then if you just decide at that point that maybe Rust isn't for you, or maybe you can't see a situation where you'll be using Rust professionally, maybe, or maybe you just plain simple don't like it very much, that's absolutely cool. That's absolutely fine. What we're saying here is these concepts that you learn through the language, through getting to grips with the borrow checker, etc., you can take that into other tech stacks, that knowledge and the confidence that you have around those concepts, and it makes you a better developer in whichever tech stack that you're working with, just because it gives you that insight into what's going on behind the code, what's going on beneath the surface. Because of course, all these things, values and references and memory management, this is all still happening in whichever technical stack you're using. But this just is a great way to get a really quick, handy insight into how it works. And I think it leaves a lasting impression on anyone who does it. Having said that, with the advent of WebAssembly, Rust is looking to enter full stack web development, and so it may be more relevant to us web developers in the future anyway. And we've got some examples of some things which are coming out of the Rust ecosystem. We've got Leptos, which is kind of like React and your Next.js. I've recently done a project here. I'm going to plug my own project here shamelessly. So if there's a version of Minesweeper, which was actually inspired by my friend Chris, who's in the call right now. He's done a Node.js version. I decided to take his idea and steal it and do it in Leptos. That is there. If anyone would like to see what it's like, it's actually kind of cool. If you open up the dev tools, you can see, thanks to WebAssembly and how powerful the tooling is, you can see how tiny the game actually is. So it actually, your browser is downloading a very small file size to get that running. Thanks, Chris. So yeah, and thanks for giving us the idea. So that's there. If anyone wants to play some Rusty Minesweeper, that is available. I'm trying to update it as much as we can. So so that's one example of where the Rust ecosystem is going. We've already got some really fantastic component-based front-end systems. So it is actually surprisingly familiar if you have done anything with React or if you've done anything with Vue, for example. They've done a really great job of understanding that people are going to be used to the JavaScript equivalent. So they've copied those paradigms across. So that's a lot of fun to work with there. And then once you get comfortable with that, there is a very recent release the last couple of weeks. Tauri version 2.0 was made stable. So now you can go ahead and you can just go ahead and make your mobile apps in Rust. The back end, let's say, of the app is native as well as it sort of transcompiles into Kotlin and Swift respectively, and you can make your mobile apps with Rust and anything you want in the front end. So I've already been playing a little bit of that. It is very new, but it's a very cool, fun thing to play with. So I very much recommend checking that out if you want to see that. And a little sort of last minute idea as well. You know, I don't want to talk about AI too much because I feel like everyone talks about AI all the time, and it's nice to sort of get off the subject sometimes. But AI has helped us so much with the sort of easier code that we have to write on a day-to-day basis. It frees us up to write the more challenging stuff, and it might give us a bit more cognitive space, if you like, to learn these more complicated things and focus on the stuff that AI doesn't do too well. Because although it is very scary when you give it something in a high-level language, it seems unbelievably good at that. If you give it Rust code, it tends to trip up an awful lot more, and it doesn't quite understand pointers, and it doesn't really understand the whole idea of borrowing or values and references necessarily all the time. So it is challenging. Just seen a message in the chat. What I find interesting is that many CLI apps are now being written in Rust instead of Go. Yeah, Rust is a great use case for the CLI apps. I have not built one myself, but I do hear it in the ecosystem and in the sort of community that it's a really great choice to go for the options it has there. I have done a little bit of parsing CLI options, and I find the pattern matching is such a great use case for pattern matching when you have like a different flags and options and things like that. So yeah, it is a favorite for that for sure. So how does someone get a better grasp on memory management and, you know, references, values? What are they? How do they work? And well, as we know, as a lot of us might know, Rust introduces the concept of borrowing. So it can seem scary if you've never touched references and values before, you never thought of pointers. It could be kind of scary to learn about that. So borrowing, what that does is it introduces something that we can think of like a mental model that takes something quite abstract and quite difficult to visualize for someone who's never had to work with it before. And it gives you a mental model which is quite clean, quite easy to visualize, and really helps to get through that learning process of getting to that new level of of thinking through problems and thinking about how to treat your code and how to treat your solutions. So as a very quick overview of what this is, the idea is that each value has a single owner variable. You can borrow things, so that's essentially references to allow temporary access without taking the ownership from the previous point. So you can have several immutable references, unchangeable references to something, or one changeable one, one mutable reference, and there are lifetimes. So we have a compiler here that will check that you're not going to try to use anything once it's expired. Which sounds like the most simple point, but as anyone will learn, that's actually ends up being the most painful part of the process. But as a very, very brief overview, that's what we're talking about. And when we combine these rules with the emphasis of the values and references expiring when they go out of scope or dying when they go out of scope, we are left with a mental model that is easy to understand for people who are new to this. So people who normally have this dealt with in the background, or people who normally have a garbage collector or a bit of both. So a common first hurdle is when someone writes some very simple code that doesn't compile in Rust when the equivalent code in a higher level language does. So I'm sure we've gone through this problem. I imagine we've all gone through this problem where the first time you want to learn some Rust, you just try to write a program that's like 5 lines long. And you think, what could be simpler than this? We're going to print out a string, we're going to change the string, and then we're going to print it out again. And then you can't get it to work. And the initial thought you probably have it is, oh, wow, if I can't get 5 lines to work, how am I going to get a system to work? I'm never going to learn this language if I can't get something as simple as printing a string to the console twice. If I can't manage that, how am I ever going to understand something like a large system, a multi-module system, or something like that? And this is an example of one of those things. If you're coming from the TypeScript world, which a lot of people who are learning Rust are from the JavaScript sort of community, you will have something extremely simple like the first example here, where it's just printing the same string twice, or processing the same string twice, I should say. And of course, 3 lines, very simple. 1 variable, and you could type that out with your eyes closed, and you know that you're going to get it working every time first try. So when someone from TypeScript comes to Rust for the first time, and they think, I'll just try writing that really simple function, and they bring it in, and they find that they already get an error here. And they go like, how is this? How can I already be having a problem? How can this already be throwing me errors? And it can make Rust seem more intimidating than it really is, because you think, like I say, if I can't do this, how am I going to do that project that I thought this would be a good use case for? And like I say, this isn't a course or an introduction to borrowing, but you can see how this mental model really helps people understand who are having these problems. So essentially, I like to think of it as thinking of the values as sort of real life objects. And it sort of brings the mental model back to that. You create a value, and there's a process that requires a value. So you give it this value, and once it's been dealt with, it will just disappear. If it's given no other option, it will just disappear. So then a second process comes up to you and goes like, can I have that value, please? And you say like, well, sorry, I've already given it to someone else. It makes sense. The idea of, if you give something to something else, it's no longer in your possession. It kind of brings coding back to sort of real life, tangible ideas. And so that's what we can see here. We get a value, we pass or move it into a function. It does what it does. In this case, it takes the value and returns void. And because that's how it's been defined, Rust will go like, no, okay, well, great. So I guess it goes out of scope. I guess we're done with this. We can free up that memory, and we're not using this anymore. And of course, that means when we want to do the second thing, as we can see in the code example at the bottom, well, it's gone. We can't use it. It's gone, which is why we have this error here. And it's just a very clear model to help people understand. I would imagine if you started out with something like C or C++, it might be a little more. It might not be as clear as to what's going on if you don't have any point of reference from before learning Rust. So if you can imagine you're learning Rust for the first time, you think like, well, how can I get this to work? And the first thing you might do in simple terms is, well, what if I just return it? Then maybe, I get that back and I could use it again. And I've always sort of thought of, it's always reminded me of that scene in Indiana Jones where he has to grab his hat right before the door closes. And I feel like the door closing is the function finishing. That's the closing of the function, and he quickly grabs his hat and saves it. So the hat is the variable here. He returns his hat right before the function ends, and that's how we get the value back out. And we can see that's what happens here. So the learner has fixed their error by getting the value. We still pass it into the same function, but here we're going to return the value instead of just returning nothing. So we'll return the value, and it survives the closing and comes back out, which means we have ownership of it again. So because it's been given back to us, when the second process comes along and says, can I have that hat in this case? We'll say like, sure, yeah, we've got it here. There you go, no problem. And there we go. And that person can fix that there. And now they've suddenly got their very simple function working because they overcame a problem which seemed, well, I remember, I can speak for myself at least, at the time it seemed so crazy why it wasn't working compared to JavaScript or something like that. And then you understand this basic concept, and all of a sudden, not only have you got it working, but you kind of think to yourself, well, of course it wouldn't work, because as you start to understand that mental model, it starts to make perfect sense. And then eventually, if you do become a sort of Rustation, it becomes your sort of preferred way of working. So we've got it working. The learner has got their code compiling. They've got their fantastic 3-line function working. So that's great. Although it's not really the most elegant solution. But they might remember what the borrow checker said back when it wasn't compiling, which was consider changing this parameter type in function our first string processor to borrow instead of owning it if the value isn't necessary. And here, I do sort of have another analogy for this. I'm not sure how strong this one is, but here we can see we started to introduce the borrowing, the references. And so we can create the reference because it's the reference and not the value itself. It doesn't matter if it gets destroyed at the end of the function because we still got the value that we can hand over. I did think of this as a way, the best analogy I could think of this was, funnily enough, as consultants. So if your consultant is at a client's office and you need some information from them, you can still phone your consultant from a different office, even though they're not with you. And then if you lose the phone number, then that's fine. The consultant can still do what they're doing where they are, but you lose that ability to call them for that information. So it's a little bit like that. And so this way we could do that, and in this way, just from following this model that the Rust team have created for this borrow paradigm, we can slowly but surely overcome these little obstacles that the borrow checker presents us and learn more and more about pointers, references, and values, which really brings us to the next big plus for Rust here. The compiler errors. Before I continue, I just realized I've been talking for an awful long time. If anyone would like to ask a question or stop me or push me for any, I don't know, if they have any observations, we can over that last bit about the borrow checker. We can take a moment to do that. I understand there's a little delay, so I'll keep an eye on the chat. But yes, compile errors. So as we know, error messages can be very helpful. They can be. It's not to say they always are. As we know, like, they can be an absolute nightmare. And this matters because seeing these concepts, and by concepts I mean in the memory management, we're talking about the references, the values, the pointers, and whatever it might be. It can already be very intimidating. And it can be even more intimidating if the immediate feedback you get from your tools is just complicating things. And oftentimes compilers can seem like they're screaming at you if you get something wrong, you know? So that's not very encouraging either. So yeah, so it's important to have something that helps, you know, a really good source of correction and encouragement in a sense. And the Rust compiler has done an amazing job, or the Rust team, I should say, has done an amazing job of providing a compiler that is exceptionally clear and also encouraging in how it provides not only clear feedback, but sometimes even a suggestion for a fix. So we've got some examples here. Again, put yourself in the mindset of someone who's learning Rust or someone who is learning Rust and hasn't ever dealt with pointers or references or having to think about values and references like that. Some of us may be in that position. You know, these errors are very, you know, it's practically English. You know, the only thing that might confuse someone would be if they didn't understand what borrowing is within the context of Rust. But you see here, it's kind of, not only is it pointing to what your error is, but it's telling you what the error is, and it tells you where your error is. It tells you not only where your error is, but it tells you specifically, you know, which characters in your code are related to the error. So we've got here, this is a mutable borrow here, and then we've got an immutable borrow. And then if you have, let's say you have a cheat sheet on your desk that says what the rules, the golden rules of the borrow checker are, you'll know immediately, oh, I can't have this. So that's excellent, clear help for those who are learning this. And they get that immediate feedback, and it's very clear. And besides the error code, it's really not screaming any sort of jargon or like crazy technical, intimidating stuff at you. It's just giving you the information if you want to look up more. It often even gives you a link, I think, as well. It can give you a link to the docs online regarding that specific error as well. We've got another one here. So this is for someone who might not fully understand the idea of lifetimes and the idea that something can expire when it goes out of scope. They want to use R, but R is really just a pointing to X, but X doesn't exist by the time we go to print the line out. And so it tells you exactly that. X does not live long enough. So in order for R to be valid, essentially, X needs to exist. And of course, like we said, you know, this is the cave door closing. And in this case, X, you know, it's sort of like a hat, you know, and it doesn't make it out. So we can't use it. The R is essentially pointing to nothing. It's essentially pointing to what we would normally call null in in a more traditional sort of sense. And so it tells you straight up. It just tells you what's going on. It tells you why it's happened as well. It was dropped here whilst it was still borrowed. So it points you in the right directions in the clearest non-technical English it possibly can. And one last one here. So yes, a similar one. We've got a moved value. So yeah, we're trying to use X, but we've essentially told Y that it's now X, which means X has no purpose. So if you imagine if you go to Y and you say, how I have the purpose of X, then what purpose does X have? So it tells you this, you can't do that, and explains you can't do that, and then it even, like we see the last one, this little help section. Well, it gives you the answer. Clone the value if the performance cost is acceptable. So it gives you a solution, and then it also gives you a little warning about that particular approach. So it's pretty great. I don't know if I've seen a compiler that is quite this helpful, which is I'm so welcome. I'm so grateful for it because, as we know, Rust has got that learning curve. So thank God it is that useful. So it's great for these beginners who come in and want to learn these things. So I'll take a little break here just to see if there is any observation anyone wants to throw in, or if there are any questions that we can discuss. I'll just take a little moment. I will give it a few seconds just because of the delay as well. That, and I've been talking so much over. I need to drink a lot of tea to fight off how dry my mouth is getting. Cool. Well, I'll go ahead and I'll keep an eye on the chat as always. So mindful design. So this is the only one that the title which doesn't crop up in a textbook, let's say, or anything like that. So I haven't really seen this talked about too much, with the exception of one video, which I will tell you about if anyone wants to look at it for their own reference. A mind for design. So what does that mean? Sometimes even once you get confident enough with the borrow checker, you might find yourself getting tied up still when you get into more complex pieces of code. So you started getting, maybe you're doing katas or something, some small coding exercises, and now you're going through them really quickly. Everything's working great. You know when to use a reference, mutable reference, you know when to clone something, all this kind of stuff. And you feel like you're a Rust developer now. It's like, all right, I've overcome the scary, intimidating learning curve that I've heard so much about. I'm away. And then you start building a real project, for example, and you're getting tied up with these more complex problems. And then you're like, well, how is this happening? I thought I understood. So this is an example I've taken from a YouTuber called Let's Get Rusty. It's a video where he points out some of the larger errors that beginning Rust developers can make. So yeah, if you look up Let's Get Rusty on YouTube, he's really great for going over these sorts of things. This is an example he had of, like, if you can imagine a game, we've got a monster, the monster can take damage. We've got a listener for a callback that will happen when it takes damage. And as you can see here, we've got a few different things like how the monster is instantiated. And then we've got a main function here that essentially just goes through the monsters and damage is received, and then essentially the game is over if the health goes over a certain amount. So these code examples aren't really super helpful. So I think we've got another slide here. Yeah. So if I've got some actual code in my environment but we can go through to make it a bit easier, because otherwise you have to flick back and forward and backward through some slides. So there's a few problems here. Counter, we've got a closure here, we've got damage that's being done. It's not happy about that. So the counter was mutually borrowed here in the previous iteration of the loop. So we've all of a sudden now we've got variables that are getting moved within loops. So like, okay, well, how do we deal with that? This value is not living long enough. And then we've got the introduction of lifetimes. That's another level of complexity that we've got going on there. And then here we've got we can't borrow it as immutable because it's still being borrowed as immutable elsewhere. So, it's like, oh, wow, this is all just suddenly exploded. We were so confident, we were getting so far, and now everything's blown up again. And unfortunately, there is a way around it. So at compile time, Rust can't guarantee from this code we've seen that the borrow checker rules will be followed, because it does always have those rules, variable, there's one owner, you can borrow it, but it has to be one mutable borrow or several immutable borrows. And then we've got the lifetimes, of course. So they are in principle quite simple rules, but when you get into very complex code, it can get more confusing. And so essentially it looks at this code and it says, I can't guarantee this. And my whole purpose, I'm supposed to be safe, supposed to be high performant. So I can't let this go through. And we won't get into this because it's quite complicated. We can get into reference counting and something called interior immutability to get around this, but this impacts performance, adds complexity, and ultimately we lose the memory safety, which is why we probably chose Rust in the first place. So that's not the right way to go about it. Ignore the thank you, because this is where we go to the code. So this is the code I've stolen from that YouTuber. And here you can see we've got a lot of errors. It's not going to compile. And so this is the version we presented as the problematic version. So these are the same errors that we've seen in the solution here. We've got counter hit, the first borrow occurs. These are all the issues we've got here on line 14. So can't borrow is mutable. It's captured. So remember the ownership. It's gone into a closure. Now the closure owns that. So there's nothing really more advanced going on, but it can seem very intimidating when you're new to it. And so because it's been given ownership, the ownership has been received by the closure, it's no longer, it's not in our possession to lend out to other parts of the code base. So, and as you can see, the lifetimes start coming up. And one mistake I made when I was learning about this, and I'm sure other people do, is when you see these errors talking about lifetimes, the tendency is to think, oh, now I have to get into lifetimes, and you think like, oh, Rust is too complex. This is crazy. I'm not going to bother with this. But actually, what this means is a mindful design. It means that it's more likely that there's just something wrong with your approach. It's nothing to do with a particular type that you need to be aware of. It's nothing to do with a particular, function, or there's no secret rule in the borrow checker that you haven't heard about yet. It's simply the borrow checker saying to you, maybe you need to take a step back and you need to look at how you're structuring your code, as you should do in any language. Even if the borrow checker wasn't here, or even if the borrow checker was happy, even, is there a better design you could be using for this? And so that's normally when you get too many errors in one go. That's normally the red flag, which is saying like, are you sure about this design at a higher level than just syntax? It's about something deeper. And so we've got this here, and then this is just a continuation of what we've already got. And the first thing that you might do, if I can get to the right this is the right one. Speaking of Git mistakes, I think this is the right one. Yep. Okay. Got a little nervous there. Right. Okay. So we've got the first fix that you could do if you look up some solutions online when you're learning as a Rust developer. You got like, what can I do about this? Because I've got this thing that needs to be borrowed several times by this given ownership several times to here, so that I can act on it. And I need to be able to do that, but the borrow checker isn't letting me. So what do we do? And you'll probably discover this type called RC, which just means reference counter, and ref cell. Don't worry, it sounds complicated. We're not going to get into it. It's not important. We understand that for this talk. It's no problem. What I want to bring attention to is look at the complexity we're introducing, is really what I wanted to say, that we're now using two types just to wrap our existing type. So there's a level of complexity there. You can see that we're doing all this sort of Rust magic to get this to work, and it does indeed compile. But the problem with this is, like we said on the slide, what we're doing here is we're essentially getting the value from Rust, which is that Rust won't let you compile it if it can't guarantee the safety. And what we're saying here to the borrow checker is like, hey, I'm pretty sure this is going to work. Just deal with it, and I'm sure it'll be fine. The borrow checker rules are still in place, but they're going to run at runtime instead. And what that means, of course, is there's no guarantees. Using these types has a performance cost as well. So it's going, even if it does work, it's going to run worse. And at the end of the day, the whole point of using Rust in the first place was to get the performance and get the safety, right? And so this is something that we try to avoid. And that's That's good. It's good in the way that you can get around it. So someone who's still in their early days, they can still sort of finish projects and still have fun, but it's not really the right way to go. And so the next solution would be to try something a little bit different. So if we go back here, so the next one would be this fix. Guess who hasn't learned their tools properly? Here we go. One last time. There's the init commit, and we want to go back to main. So if files, okay. Not sure why that wouldn't let me do that. Let's see if I can just pull that up. Give me a second. Git checkout. Where are we right now? Oh, there we go. 846. It should be fine. Oh, it is in the right place. Sorry. I'm in the wrong one. There we go. So fix the code of ref cell, and then the next one should be this one. Yeah, we want to check this one out. There we go. Sorry about that. So the next thing we do is essentially we want to, the problem is having those closures. We've got those temporary things getting put into those closures. So something else that we can do instead is, that's main monster. Yeah, so we've got damage received. So there's just a bit of restructure of code. So essentially what we're doing here is the problem, as is often the case with these sorts of problems, the problem is that you're holding a reference to something for too long. And so what that means is if you can imagine you're grabbing a reference to something and then you plan to do 100 procedures with it, what happens is then things start to get complicated because then some point in those procedures, there's a new scope that needs to borrow that or needs to do, you're complicating your code base. And so something that you can do is you can try to think more simply about this, and you go like, okay, well, let's do this, and then let's do this procedure, this one process, and then let's get that out. Or in this case, what we're talking about is if you have a large object which has got nested within it other properties, and you pass in that entire object, then that entire object is now being used up. Let's say that's the one that's being focused on. That's the one that you can no longer share with other procedures, with other functions like that. So that element of design comes in where you think to yourself, should I be giving this function this entire object if I only really need to access this one particular property? This is the same kind of principle that we approach with permissions and roles. If you think about it, you only really want to give a user the minimum privilege that they need in order to do their job. And this is the same thing. You only really, and you think of it with modulation. Sorry, that's guitar playing coming to my head. Modules. If we only want to give access to properties and functions to the rest of our system that is necessary. Otherwise, we'd make everything public all the time, and then we start exposing things to like functions or properties to other modules of our system, which we shouldn't be doing, and that ends up producing a system which doesn't have very good encapsulation to it. You start getting strange interdependencies and all kinds of messes. And so what this is yes, the borrow check is yelling at you, and in the past it was because you were using the wrong type or you weren't passing the reference when not passing the reference when you could have been, etc. And in this case, actually, it's more about you as a developer. It's actually more about there's something wrong with your design, not the wrong type, not this, not that. Look at your design. Is there something you can improve that would get around this? Because it offers you the get out of jail free card, or like the cheap way to get out, or the cheating way to get out, which is like the special ref cell, whatever it might be. But at the end of the day, what the message it's really giving you is maybe you need to think twice about your design. And we are just about to finish. There is just one more commit, which I just wanted to show off as well. I believe it's this one. I think we've got a summary or Let's check it out. Attack summary. So yeah, so in this case, you can see in the diff here, we've got an attack summary. So what that is instead of nesting processes within each other, where you're holding on to this reference for a long time, instead, what this attack summary represents is do one thing and then pass the summary back to your main process and say like, okay, well, this is the result of that action. And what that means is now you've got a new object which you can pass forward, and it has no bearing on the properties that made it up. So it frees up that memory, it frees up that object, so it can be passed on further. And that's the real way, let's say, of getting around these problems. Is it teaches you the lesson of system design, and it teaches you that lesson about how to design your API, how to structure your code, and that way you can get around the errors that we're seeing without overcomplicating things and without introducing that extra complexity. And in a sense, actually, the answer to the complex problem is to go more simple, which is I think it's quite a cool lesson that kind of comes out but emerges from these borrow checker rules. And I think it's an important lesson that you can take away to your .NET job, or you can take it away to your TypeScript job, or whatever it is you're doing. And it just helps you to design APIs and systems a bit more coherently like that. Right, so that concludes the presentation. So we can go back to our final slide. So thanks very much. That is a new Git tool in my NeoVim, and it was probably a little bit ambitious to start using it on the live presentation, but we got through it in the end. So thanks very much for bearing with me. If there are any questions or any comments, I'm sure Mattsi and I will be more than happy to answer them the best we can.
Thank you, Cam, for this nice presentation. We can wait for maybe some seconds to see if someone else in the audience has some questions for you.
Hey Cameron, thank you so much for the session. It was great. I'm not sure if my previous messages were visible or not. I pinged them onto the meeting group chat, but thank you so much. Really appreciate this. Thank you.
Thanks very much. Thanks very much for coming. I'll have to see if I can find the chats you were talking about. I was so focused on the actual presentation. Sorry, I didn't get a chance to see your messages come through, but yeah, I'll see what I can find. Was it a question you had or anything like that I could respond to now?
No, I was just saying that, so I'm starting with Rust, but I have worked in C++ for quite some time. I thought that the borrowing concept is quite similar to what the reference count smart pointer is in C++. So I just pinged that. Yeah, that's all.
Yeah, so unfortunately, I don't really have an experience in C++, but the reference counting in the case here, so what I should have said as well in the presentation was there are use cases where it is completely fine to use these powerful pointer types like the reference counter, ref cell, interior immutability. There are cases where it's necessary and it's the way to go. What I should have illustrated a bit more clearly there was that they are extremely powerful tools, and so it can solve your problem if you get into these if you start getting into this spaghetti problem where you've got references pointing to strange places and you've got closures that need ownership inside of an iterator. And it's kind of like the analogy of like, if you try to kill a fly with a cannon, or like you try to kill a fly with a hammer, it's like you can do it, sure, but it's it's maybe not the most elegant tool for the job. And so you can get around the problem like that, but of course you pay a cost of performance, and pay, well, a massive cost in the code becoming unsafe again. And so, yeah, I don't know what the reference, I assume the reference counter must do something similar in C++. In this case, I suppose that's quite an interesting point because the C++ doesn't have the borrow checker rules or the borrow checker at all. I suppose it doesn't sort of push you into the design, into restructuring the code as a whole, I would assume. So
yeah. Sorry. Didn't mean to interrupt you. Sorry.
no, I was done. That's fine.
Okay, yeah. So CPP doesn't have the concept of borrowing, like Rust has. So the reference count, as the name suggests, it keeps a count of how many references currently are there on a particular pointer, and then once different reference counts are removed, the count also decreases, and once it reaches 0, then the destructor is called and the memory is deallocated. So yeah, it works like that. As I said, I'm just starting with Rust, so I'm not much sure of how that the borrowing internally works, but you were explaining greatly, so, and I figured that there may be some kind of relationship between these two concepts. So yeah, but great session.
Like, to the best of my knowledge, the reference counter does exactly what you just described in the Rust context as well.
Okay.
So yeah, and just to answer Christian's question in the chat, the runtime cost of refcell really so harmful in internal mutability. So the short answer is, so perhaps I can only speak about the experience I have or the knowledge I have, and of course I'm still learning myself. From what I've heard from far more experienced Rust developers say is essentially it is a high cost to pay if you can't fix it through changing your design. So there will be problems where you need to have interior mutability and you need to have reference counters and things like that. That's why they're in the language. There are situations where they are necessary. The problem only arises when it's used as an easy shortcut to solve a problem, which could be solved by design. So one of the costs we're talking about, the runtime cost, yes, there is a performance cost, and I assume or believe there is a memory cost as well. But the cost, it comes from really you're sacrificing the safety, which is what we wanted Rust for in the first place. So I hope that answers the question, Christian. And the most important difference between the borrow checker in Rust and ref counting in any language, including Rust, is that borrow checker works in compile time, but ref count is a runtime concept. Yes. So that goes back to the cost of using interior mutability, let's say, and it's the safety, right? So you're like we said in the presentation, you're essentially saying to the borrow checker, trust me, I'm pretty sure this is going to be fine. Nothing can go wrong here. And obviously, those are the famous last words for anyone that's ever said that. If anyone's about to say there's no way this can go wrong, stuff normally goes wrong. So yeah. So there's nothing inherently bad or wrong with those types. Of course, it's just if don't use a hammer to kill a fly. So it's about finding a more elegant solution where we can still reap all the benefits of the technology that we're using, just by knowing a few principles and just from understanding what good design might look like. Okay, I think those are all the questions.
Okay, Cam. So thank you very much for this super interesting presentation. And now for the people watching this video, we will have another speaker. We are going to switch languages to Spanish, but we will keep ourselves in the same language, which is Rust. Y ahora tendremos a Dayana Rodrigues, que nos va a hacer una presentación sobre Rust, Solana y cómo construir smart contracts con Anchor. os dejo con ella. A ver si esto funciona. Sí. Ahí va. Gracias.
Recording stopped.
Oh, sorry.
Sí, acabo de enterarme. ¿Qué tal? Vale. Hola a todos, mi nombre es Dayana Rodrigues y yo formo parte del equipo de Heavy Duty Builders, que somos una comunidad de desarrolladores que estamos a nivel mundial y nos enfocamos sobre todo en desarrollo blockchain y principalmente en la blockchain de Solana. Y el día de hoy pues les traigo esta pequeña charla de cómo pasar de ser un desarrollador Rust a ser un desarrollador en Solana. Y pues para hablar de Solana necesitamos un poco conocer de qué va esto de Solana justamente. ¿Qué pasa aquí? Ahí está. Y pues vamos a hablar entonces un poco sobre qué es Solana. Solana no es más que una blockchain y para los que no estén familiarizados pues con este tipo de tecnología, la blockchain no es más que un sistema, digamos, descentralizado que lo que hace es almacenar datos. Imaginemos un poco una base de datos que en lugar de estar centralizada en un solo nodo, es una especie de base de datos que está distribuida en diferentes nodos, lo que hace pues que sea un poco más segura, digamos, para almacenar datos. Esta blockchain que está acá pues se diferencia de otras blockchain justamente porque es una plataforma de alta velocidad, de alta eficiencia y que es capaz de manejar miles de transacciones por segundo. Estos, si conocen un poco acerca de blockchain, saben que es algo que no todas las blockchain logran. Y en el caso de Solana, pues el número que se maneja, digamos, en teoría, es de 65.000 transacciones por segundo, que es un número bastante elevado en términos, pues, de transacciones manejadas por este tipo de redes descentralizadas. Y Solana, pues, se ha vuelto súper popular, sobre todo por las tecnologías core que ha implementado para hacer justamente que esta blockchain sea tan distinta en términos de eficiencia al momento pues de escribir y de obtener datos de esta red. Y es sobre todo su mecanismo de consenso que se conoce como el Proof of History, que pues lo que hace es tratar de mantener, digamos, un reloj descentralizado entre cada uno de los nodos que son los que se encargan de validar todas las transacciones que ocurren dentro de la red, de manera que los nodos no tienen que esperar a que los otros nodos validen todas las transacciones, pues para, digamos, hacer que una transacción ya esté escrita de forma válida dentro de esta red descentralizada. Y pues para comunicarse o todo lo que se hace, digamos, dentro de esta blockchain y dentro de todas las blockchains se hace a través de lo que se conoce como contratos inteligentes. ¿Qué es un contrato inteligente? Un contrato inteligente no es más que un programa o un pedazo de código que se ejecuta directamente en la blockchain de forma automática. Y este tipo de código lo que hace es que nos permite comunicarnos con la red, nos permite hacer cambios sobre los datos que estén almacenados en la red y pues también consultar cosas allí. Sin embargo, los contratos inteligentes no son la única forma que tenemos de comunicarnos con la blockchain, sino que también existe lo que se conoce como dApps o aplicaciones descentralizadas. Las aplicaciones descentralizadas no son muy diferentes a las aplicaciones normales, digamos, comunes que vemos hoy en día y que tienen una interfaz de usuario que todos sabemos utilizar, con la única diferencia es que en la parte, digamos, del backend, en lugar de comunicarse con una base de datos tradicional, lo que hace es a través de una API se conecta pues directamente a la blockchain y pues realiza, digamos, estas llamadas a través de transacciones e instrucciones que van a través de estos contratos inteligentes que vimos anteriormente. ¿Por qué entonces elegir, digamos, Solana si te quieres convertir en un programador blockchain? Por varias razones. Una de ellas, pues, la que vimos que es la principal y es la escalabilidad y el rendimiento excepcional que tiene esta blockchain en comparación a las otras. Sin embargo, una de las cosas que también lo ha hecho, digamos, más famoso y popular desde el punto de vista de los desarrolladores es que tiene bajos costos. ¿Qué significa esto? Que el realizar transacciones, el hacer deploy de tus contratos inteligentes a la red, pues cuesta mucho menos de lo que te costaría en cualquier otra blockchain. Además, nos ofrece un montón de frameworks y herramientas que hacen que el desarrollo de programas y de contratos inteligentes en esta red sea muy sencillo, que la curva, digamos, de aprendizaje para comenzar a programar el día de hoy en Solana sea bastante, digamos, baja, ya que tenemos un montón pues de herramientas de documentación y de recursos disponibles que cada día pues son más y cada vez están incluso en más idiomas. Y por supuesto, la gran comunidad que tiene Solana de desarrolladores y de el ecosistema en general que está en crecimiento, ya que esta blockchain está básicamente nueva, es una blockchain, un proyecto que no tiene tantos años en el mercado y pues que está en crecimiento y todo el tiempo pues está buscando mejorarse. Pues para comenzar entonces a hablar ya de un poco de cómo sería desarrollar en Solana, hay ciertos conceptos básicos que necesitamos conocer sobre Solana y cómo funciona la red de Solana. Lo primero que vamos a hablar es acerca del modelo de cuentas de Solana, que es, digamos, el concepto core o el concepto principal que debemos conocer si queremos adentrarnos en el mundo de cómo funciona Solana y cómo entonces programar estos contratos inteligentes en Solana. Lo segundo que vamos a hablar es acerca de los programas y de qué significa esto de un programa en Solana. Y luego pues vamos a ver entonces cómo utilizar Rust para desarrollar estos programas y contratos inteligentes en Solana. Lo primero entonces que vamos a discutir es acerca de este modelo de cuentas. ¿De qué va este modelo de cuentas? Pues lo primero a saber es que en Solana todo es una cuenta. Todo. Podemos imaginar Solana como una especie de diccionario clave-valor, donde la clave, digamos, sería una dirección asociada a cada cuenta y el valor, pues, sería una cuenta. Absolutamente todo está almacenado en cuentas. Contratos inteligentes, valores de tokens, informaciones relacionadas, pues, a cuentas que interactúan con contratos inteligentes, todo almacenado en una cuenta. Eso es un concepto que es, digamos, el primer concepto que se tiene que introducir a la hora de empezar a desarrollar en Solana, ya que cada vez que hablemos de una cuenta o de un account, tenemos que tener claro de que todo en Solana se maneja con esa estructura como tal. Luego de eso, vamos a ver que cada cuenta pues tiene un propietario, que es un propietario único y es el único que tiene, digamos, potestad para cambiar o actualizar qué datos o qué cosas se está almacenando dentro de esa cuenta, bien sea una información o bien sea incluso el código de un smart contract. Y otro concepto que también es importante y que no voy a adentrarme, digamos, demasiado en él, porque al principio suele ser un poco complejo, es el tema de la renta. La renta es un concepto que se utiliza en Solana para mantener, digamos, la blockchain un poco al día con la cantidad de información que se almacena y que no está, digamos, olvidada, sino que siempre cada una de las cuentas que creamos tiene que tener, digamos, una pequeña cantidad de fondos. Estos fondos, pues, representados en la moneda de Solana, en el token de Solana, pero, digamos, en su versión pequeña, que se conoce como lamports, y todas las cuentas deben tener un mínimo digamos, de lamports almacenados en sus datos, pues para mantener, digamos, esta cuenta disponible siempre para usar, digamos, en la red a través de contratos o de transacciones, etcétera. Entonces, cosas importantes, la renta es un concepto que hay que tener claro a la hora de uno programar, pero como usuario a lo mejor externo de la red, no es un concepto del que se deban preocupar. Pero como estamos viendo esto desde el punto de vista de los desarrolladores, al momento de que queramos crear una cuenta, hay que tener entonces siempre presente que esas accounts que vayamos a crear, pues tienen que tener esta renta siempre disponible. Y entonces hablemos, ya que vimos un poquito acerca de estas cuentas, vamos a hablar entonces de los programas en Solana. Los programas en Solana es lo que sería equivalente a tener un contrato inteligente en cualquier otra blockchain, solo que aquí se le conoce como programas. Y para comunicarte con la blockchain, lo que hace es que enviamos transacciones que vienen con un conjunto de instrucciones que son las que invocan a estos programas y es a través de los programas que se ejecutan cambios dentro de la blockchain. Estos programas se dividen en dos tipos, digamos, principales. El primer tipo son los programas de sistemas, que son programas, digamos, de Solana como tal, del core de la red, y son programas que ya tienen funcionalidades básicas y sobre las cuales se desarrollan lo que se llaman programas de usuarios o programas personalizados, que esos serían los programas que escribiríamos nosotros, por ejemplo, y que pues, por supuesto, en lugar de estar creando, digamos, un programa desde cero, podemos utilizar estos programas, que es algo que también es bastante novedoso de Solana, que podemos construir programas a partir de otros programas que ya existen en la red. Y entonces utilizaríamos estos pequeños programas del sistema que manejan cosas como tokens, como creaciones de NFTs, como a lo mejor instrucciones relacionadas con el governance, por ejemplo, y que nosotros podemos entonces escribir otro tipo de lógica que esté asociado con esta funcionalidad sin necesidad de escribir todo el código, sino conectándonos directamente con esos otros programas a través de algo que se conoce como el Cross Program Invocation o invocación entre programas, que lo que hace es que nosotros desde nuestro código de programa podemos invocar a otros programas de la red que ya existen. Ahora, ¿qué necesitamos entonces para comenzar a desarrollar estos programas en Solana con Rust? Vamos a necesitar dos cosas. Primero va a ser el Solana CLI o la interfaz de línea de comandos de Solana. Vamos a hablar entonces del Solana Program Library también, que es justamente este conjunto de programas que utilizamos como base para desarrollar otros programas en Solana. Y pues por supuesto necesitamos Rust. Vamos a comenzar entonces con la interfaz de línea de comandos de Solana. Esta interfaz, digamos, es lo primero que se necesita al momento de adentrarte en este mundo de desarrollo de Solana. ¿Y por qué es como el primer paso o la manera más directa en la que podemos conectarnos y comunicarnos con la red? Sencillamente a través de una serie de comandos del terminal. Con el CLI podemos hacer cosas como crear tokens, invocar programas que ya estén deployados en la red, podemos consultar el estado de la red y hacer un montón de cosas simplemente a través de unos comandos. Sin embargo, esto obviamente no nos permite hacer, digamos, una serie de lógica más compleja porque estaríamos interactuando con la red simplemente a través de una lista de comandos pues ya predefinidas. Aquí yo les dejo un pequeño videito de cómo funcionaría. Primero estamos instalando este CLI y luego estamos viendo cómo funciona, estamos verificando que se instaló correctamente y vemos entonces la lista de comandos que tenemos allí definidos, pero sencillamente es utilizar todo y conectarse directamente a esta red de Solana desde la simplicidad de una terminal de comandos. Ahora vamos a hablar un poquito acerca del SPL o de la librería de programas de Solana, que es este conjunto que les comenté de programas que vienen ya como predefinidos, que son ya programas de la red y que pues no son programas que podemos cambiar, porque a diferencia de los contratos inteligentes que nosotros desarrollaríamos, que podríamos actualizar, estos programas solamente cambian cuando se hacen actualizaciones en la red, porque son programas, digamos, core de la red de Solana. Y se utilizan justamente como base para desarrollar otros programas y para desarrollar dApps también, ya que sin necesidad de escribir un contrato inteligente nuevo, podemos utilizar esta serie de programas a través de la API de Solana para llamar a esta serie de programas que ya existen y crear una dApp que funcione a lo mejor basada simplemente en las funcionalidades que nos proveen este tipo de librerías ya predefinidas. Y por supuesto, si queremos programar Solana con Rust, vamos a necesitar Rust. Y Rust, a pesar de que, bueno, en Solana se puede programar en otros tipos de lenguajes, Rust es el más popular, el que tiene más soporte y el que se le han construido también, digamos, más herramientas, más bibliotecas y es, digamos, también el favorito para los programadores en Solana. Sin embargo, a pesar de que, bueno, Rust es tan soportado, tiene pues ciertas diferencias al momento de crear programas como tal en Solana, siempre que estemos hablando de programas utilizando Rust nativo, porque a la hora de utilizar cosas como frameworks para escribir programas en Solana también en Rust, pero a través de cierto framework no es exactamente igual, pero basándonos de que estamos intentando utilizar solo Rust para escribir programas en Solana, pues tenemos ciertas diferencias que hay que siempre tener en cuenta si ya por lo menos tienes experiencia como programador de Rust. Que por cierto, si tienes experiencia, pues tienes, digamos, ya la mitad de la curva de aprendizaje lista. Así que es como un punto positivo si ya eres un programador Rust que quieres ahora entrar en el mundo de la blockchain. Y pues la primera, digamos, diferencia clave que hay es las dependencias del proyecto. Siempre que queremos crear un programa en Rust para Solana, necesitamos agregar una dependencia que es el create Solana program. Esto va a ser requerido ya que de este create es que se obtienen tanto las funcionalidades a estos programas que ya vimos que tenemos, también ofrece los tipos de datos y las estructuras de datos con las que vamos a manipular estas cuentas, que es la unidad, digamos, base de almacenamiento de Solana, y que necesitan pues ser serializadas y deserializadas para poder utilizarse, y es este crate el que nos ofrece, digamos, todo este tipo de estructuras y de funcionalidades para entonces poder manejar estos datos que queremos, digamos, almacenar o leer de esta blockchain. Otra cosa que se diferencia es que a pesar de que los programas en Solana siguen siendo programas en Rust y que la estructura sigue siendo similar con nuestro directorio source y nuestro archivo cargo de configuración, pues el punto de entrada a nuestro programa sí cambia. A diferencia de lo que sería, digamos, un programa regular en Rust, no tenemos nuestra típica función main, sino que utilizamos una macro que se llama el entry point y que recibe una función que se define con ciertos parámetros relacionados con las instrucciones que manipulan las cuentas asociadas a este programa y un identificador único que también va asociado a ese programa, que es el identificador de la cuenta donde se almacenaría, digamos, ese programa en la blockchain. Este, digamos, punto de entrada o entry point es el que se llama siempre que una instrucción intenta invocar a este programa. Y aquí está un poquito un ejemplo de cómo sería ese punto de entrada en Rust, que en lugar de ser esa función main es este entry point que recibe esta pequeña función, que lo que tiene entonces es ese ID del programa, tiene una lista de cuentas que están asociadas a mi programa o que son necesarias para ejecutar las instrucciones de ese programa, y pues la instruction data, que lo que es la data relacionada a las instrucciones pues que invocan o que utilizan este programa. Otra cosa en la que se diferencia también es la manera en la que construimos las pruebas, en la que construimos los programas y realizamos las pruebas. A diferencia pues de un programa regular, para nosotros poder compilar un programa en Solana tenemos que hacerlo con un formato específico que es el bytecode necesario para que este programa pues pueda ejecutarse directamente en la red de Solana. Es por eso que para hacer el build de un programa que ya hemos escrito utilizamos pues dos comandos que son diferentes a lo que realmente utilizaríamos en un programa regular de Rust, que sería el build BFP o el build SPF, que lo que hace es pues compilar de igual manera nuestro programa, solo que en este bytecode necesario para poder entonces hacer el deploy y que corra en nuestra red de Solana. Y también para hacer pruebas junto con el CLI de Solana viene lo que se conoce como el Solana Test Validator, que es un pequeño programita que se corre para levantar una pequeña instancia local de Solana en la que puedes deployar tu programa, ejecutar tus instrucciones y probar que todo funcione antes de hacer este deploy, digamos, a la red de producción, por decirlo de alguna manera, de Solana. Y aquí yo tengo un poquito cómo sería este funcionamiento de ese Solana Test Validator. Lo primero que tenemos que hacer es que cuando instalamos el Solana CLI vamos a tener un archivo de configuración. Ese archivo de configuración de Solana nos dice a dónde estamos apuntando, a qué RPC. Ese RPC es, digamos, entornos de Solana que están divididos en entornos de desarrollo, entornos de testing y lo que se conocería como el main, que es el entorno de producción. Entonces, para correr este test validator y poder probar nuestros programas de forma local, tenemos que primero setear esa configuración de Solana a nuestro localhost. De manera que levantamos nuestro Solana Test Validator y luego todo lo que realicemos a través de la línea de comandos utilizando ese Solana CLI se va a ejecutar dentro de este validador local que nosotros pues estamos ejecutando. Si se fijan, ahí yo estoy comprobando que justamente el primer hash de esa blockchain o ese digamos, validador que estoy subiendo allí de esa copia local de Solana es el mismo al que estoy justamente levantando con mi Solana Test Validator. Y bueno, también pues por las características, digamos, que tiene esta red de Solana, ya que necesitamos manejar un poco mejor los recursos que se utilizan pues para poder ejecutar cosas de manera correcta en la red, y además todo se tiene que ejecutar de forma determinística. Hay ciertos paquetes que no están disponibles para su uso cuando estamos desarrollando programas en Solana, y hay algunos que, a pesar que sí están disponibles con ciertas limitaciones. ¿Esto por qué ocurre? Pues justamente, por lo menos aquí les tengo un poco una lista de cuáles serían estos paquetes que no están disponibles y cuáles están limitados en funcionalidad. Si vemos el ejemplo, el primero que está listado allí es el rand. Rand no está disponible porque al intentar pues generar números random, eso no se hace nunca de forma determinística y por lo tanto no está soportado por la red de Solana. Incluso si tenemos paquetes que dependen de rand, esos paquetes tampoco van a estar disponibles para utilizar al momento de desarrollar programas en Solana, a menos de que pues se coloque alguna configuración, digamos, específica, y que siempre utilicemos alguna funcionalidad de este crate que depende de RAM, que no genere números random o no genere nada que no pueda ser calculado de forma pues determinística. Otro cambio que es un poco, digamos, más normal, pero que sigue siendo también un cambio, son cambios en algunas macros que estamos acostumbrados a utilizar en Rust, y sobre todo son estas que se utilizan para imprimir mensajes en pantalla o para hacer logs. Y es que en lugar de utilizar el típico print line que utilizamos al desarrollar Rust, en Solana esa macro se actualiza por una macro que es la macro de mensaje o MSG, y lo que hace es que en lugar pues de registrar esto en la terminal, lo que hace es hacerlo como parte de los logs del programa. Y todo, digamos, lo que se tradicionalmente en Rust se ve como una salida de información al usuario, para Solana lo único que hace es escribir esto en los logs del programa. Esto incluye también cosas como los panic y como los asserts, que siempre pues nos dan un poco de información acerca de por qué sucedió ese pánico en nuestro programa, pues también vendría guardándose dentro de los logs del programa. Y por supuesto, también tenemos algunas cositas como los frameworks, que también cambian un poco en cómo se desarrollarían los programas en Solana. Todo lo que hemos visto hasta ahora ha sido entonces para desarrollar, digamos, programas nativos, y si intentan utilizar algún framework para desarrollar también Solana utilizando Rust, van a ver que la mayoría de estas cosas aplican, pero a lo mejor hay algunas que no. Sin embargo, pues hay formas de comenzar hoy sin necesidad de toda esta, digamos, introducción que les di acerca de qué cosas tener en cuenta, cómo probar y cómo esas cosas que facilitan, digamos, ese camino a convertirte en un programador de Solana. Y entre ellas, pues están ciertos entornos de desarrollo disponibles para los programadores y los frameworks que te hacen 100% la vida mucho más fácil cuando estamos desarrollando en Solana. Del primero que vamos a hablar es del entorno de desarrollo Solana Playground, que es un entorno de desarrollo que está disponible en la web a través de un navegador y que te permite hacer muchísimas cosas interesantes. Te permite crear programas completos de Solana, no solo utilizando Rust, sino utilizando Rust con otros frameworks y también pues utilizando otros lenguajes de programación. Te permite también utilizar el Solana CLI, te permite testear tus programas, hacerles deploy, conectar wallets, hacer un montón de cosas interesantes desde la comodidad pues de tu navegador, sin necesidad de tener que instalar absolutamente nada ni configurar ningún entorno de trabajo. Otra cosa interesante que tiene el Solana Playground es que también tiene ciertos tutoriales y plantillas de otros programas que te pueden servir para aprender y para tener, digamos, programas bases a partir de los cuales desarrollar nuevos programas en Solana. Sin embargo, si quieres pues crear un proyecto ya bastante más grande, más complejo, o estás intentando hacer tu propio programa con un equipo, vas a necesitar pues desarrollar en tu entorno local de trabajo, y ahí es donde vienen pues a salvar la vida un poco los frameworks. El framework más famoso y el que tiene más soporte actualmente en Solana para Rust es el framework que se conoce como Anchor. Este framework lo que hace es simplificar bastante el proceso pues, de desarrollo de programas, ya que nos quita lo que sería en mi parecer, lo más confuso, que es toda esta parte de tener que deserializar y volver a serializar la data cada vez que estamos intentando manipular la data pues, de un account. Esto Anchor lo hace un poco por nosotros y también nos permite hacer que nuestra programación sea un poco más declarativa y el código pues termina siendo bastante más simple y más corto. Hoy en día también están saliendo nuevos frameworks, entre ellos también está este nuevo framework que se conoce como el framework Steel, que está también ganando bastante popularidad, principalmente porque proporciona una estructura de proyectos bastante definida que le da a los desarrolladores la oportunidad de tener, digamos, el proyecto organizado siempre de ciertas formas específicas y de paso también ofrece ciertas plantillas predefinidas dependiendo del tipo de programa o de smart contract que quieras desarrollar para Solana. Este framework, a pesar de que está muy nuevo y que todavía está un poco en construcción, ya tiene bastante documentación y está disponible para utilizar. Y por último, los recursos que tenemos disponibles nosotros los desarrolladores si queremos aprender sobre Solana y a desarrollar de Solana. Lo primero que hay que revisar siempre, por supuesto, es la documentación oficial, que en este caso sería la documentación oficial de Solana. Sin embargo, el equipo de Solana también ha, digamos, puesto bastante esfuerzo en que la comunidad de Solana como tal también ponga a disposición de los programadores un montón de recursos disponibles y un ejemplo de esto pues es el libro de cocina de Solana o el Solana Cookbook, que tiene un montón de ejemplos y que te ayuda pues a ir poco a poco entendiendo los conceptos como el concepto de las accounts, qué estructura tienen las transacciones, las instrucciones y todo eso un poco también de forma práctica a través de ejemplitos. También ofrecen un montón de cursos en línea, tanto del lado de Solana como del lado de las comunidades y por supuesto repositorios públicos en GitHub donde hay un montón de ejemplos de programas, desde programas súper básicos hasta programas más complejos. Yo les dejé por acá un QR que va a irles a un Git que tiene solamente un montón de links con algunos de estos recursos que les mencioné. Si alguien está interesado pues, en saber y acceder directamente a estos recursos, a la documentación, a los frameworks y a todo lo que les comenté hace poco, pues este es el QR. Se los voy a dejar unos segunditos solamente para que puedan leerlo si les interesa. Pero lo que tiene es realmente un montón de recursos que, digamos, los va a ayudar a comenzar ese camino de aprender a desarrollar en Solana. No sé cuánto tiempo dejarlo, pero bueno, continuar allí. Y cualquier cosa se les pasa luego el link del GitHub por allí. Y por supuesto, hablarles un poquito acerca de mi comunidad, Heavy Duty Builders, y de lo que hacemos. Y comenzamos diciendo, por supuesto, que somos una comunidad global de desarrolladores que buscamos justamente es crear eso, una comunidad donde podamos compartir conocimientos y aprender los unos de los otros. Somos apasionados pues por todas las nuevas tecnologías y siempre estamos intentando estar a la vanguardia de todo. Por eso es que nos gusta tanto participar en un montón de eventos que nos permitan conectar con otros desarrolladores que puedan también aportar a la comunidad puntos de vista, digamos, innovadores y creativos. Parte de las cosas que hacemos y de lo que vengo también a promocionar aquí es que ofrecemos formaciones gratuitas a lo largo de todo el año, principalmente para aprender sobre Solana. Y justamente este lunes vamos a comenzar un nuevo bootcamp en el que vamos a aprender a hacer una dApp basada en el contrato inteligente que hicimos en el bootcamp pasado. Esa información del bootcamp pasado también va a estar disponible, pero si les interesa entonces aprender cómo entonces funcionaría una dApp con un contrato inteligente custom, que fue el que hicimos en el bootcamp pasado, pues este bootcamp está bastante interesante. Vamos a utilizar React para hacer el front de esta dApp y nos vamos pues a estar conectando con ese smart contract que estuvimos haciendo en el bootcamp pasado. Así que desde acá pues están 100% invitados a participar, es completamente gratuito, lo hacemos a través de nuestro Discord, el Discord de Heavy Duty Builders, y todo lo manejamos a través de allí. Vamos a tener 3 clases a la semana durante un mes seguido, en el que vamos a estar aprendiendo sobre bases teóricas acerca de Solana y acerca de React, y vamos a estar haciendo proyectos semanales que nos van a ayudar entonces, digamos, a soltar un poco las manos y empezar a escribir entonces dApps de manera mucho más rápida y sencilla con todas estas tecnologías. Y les dejo por acá también un poquito acerca de una nueva comunidad que acaba de surgir y que acaban de hacer el lanzamiento justamente el día de ayer, y es la comunidad de la familia. Y la familia es súper interesante porque está 100% enfocada a la comunidad de Solana en España. Es decir, estamos intentando pues impulsar proyectos españoles, 100% españoles en el ecosistema, intentando impulsar que parte de la documentación y de todas las cosas que se realicen en Solana también esté disponible 100% en español, y tratar pues de, digamos, de que todo se vuelva un poquito más ameno para esta comunidad de España. Así que los invito a seguirlos. Ese que está allá es el handle de Twitter o de X, como se dice ahora, para que sigan a la familia y estén pendientes de todos los eventos y de todas las cosas que la familia trae para ofrecer. Y ahora sí les dejo por acá un QR que lo que tiene realmente es el Linktree de Heavy Duty Builders, para que puedan acceder también a nuestro X, a nuestro Discord, a la página del bootcamp donde se pueden registrar si les interesa participar en el bootcamp. Y bueno, ese sería todo por hoy acerca de pues, esta pequeña introducción de cómo convertirte en un programador Rust, programador de Solana, si ya sabes un poco de Rust. Y bueno, si tienen alguna pregunta, quedo aquí pendiente del chat. No sé cómo hacer esto del chat, a ver, con lo del delay.
De momento, parece que no hay ninguna.
Perfecto.
Dayana, te iba a preguntar, yo te iba a decir sobre
Ajá.
el workshop, todo esto, pero veo que ya lo tenías ya preparado perfecto todo. Así que, nada, yo suelo decir que muchas gracias. Personalmente he asistido a 2 de los workshops que habéis impartido, el último de tu mano, y tengo que decir a todo el mundo que nos vea que recomiendo encarecidamente que asistáis a estos workshops porque son oro puro y además son gratuitos, como dice ella. Así que,
Sí.
de verdad, si estáis interesados en temas de Solana, blockchain, y vamos, os lo recomiendo mucho, mucho, mucho. Yo solo te quería hacer una pequeña pregunta, pero que también has hablado
Sí,
de
claro.
ello, porque vi que había salido este framework Steel.
Sí.
Y mira, has hablado también de ello. No sé si lo has llegado a probar o si...
No lo he probado todavía, no he tenido la oportunidad tristemente, pero sí me interesa bastante porque lo poco que he leído, sobre todo la parte que tienen estas estructuras ya predefinidas de programas ya listos, que quiero echarle un ojo a ver qué tan, digamos, estructurado está ya el programa y qué diferencias hay, sobre todo con el framework Anchor. Quiero ver qué tan distinto sería el migrar, digamos, de un framework que ya todo el mundo está acostumbrado, que es el Anchor, a un framework nuevo. Y tengo pendiente hacer eso, pero se los quería traer a colación porque a mí me emociona un poco que haya cada vez más cosas que hacer, porque parte, digamos, de lo que hace todo esto interesante es que haya diversidad y que uno pueda, digamos, escoger qué es lo que más le gusta. Entonces, si querías utilizar un framework para Rust, antes solamente tenías Anchor, y que ahora esté saliendo un nuevo framework es bastante interesante y abre bastante las oportunidades a que decidas dónde te sientes más cómodo y qué cosas a lo mejor necesitas dependiendo de que estés construyendo en Solana. Entonces, sí, lo tengo pendiente por utilizar, pero es algo que está súper, súper interesante de ver, y se los dejo allí para que lo investiguen. Y bueno, a ver qué tal, qué tal. Esto es bueno porque va a impulsar a que cada vez salgan más y más cosas en Solana para Rust.
Correcto. Y bueno, yo espero el próximo workshop que hagáis sobre este framework. O sea, la versión que hicimos
de
con
Anchor, pero ahora con Steel.
Con Steel. Esto ya, ahí estaremos. Sí, sí, sí.
Allí estaremos, sí. Eso también viene. Vamos a ver qué nos organizamos para el próximo año en esta serie de cursitos que siempre hacemos en Heavy Duty. Y bueno, un placer estar aquí. Gracias por invitarnos.
No.
Nosotros encantados de participar en este tipo de eventos con ustedes, como siempre.
Sí, espero que no sea la última vez.
No,
yo espero que
esperemos
podamos
que no.
hacer más de estos y bueno, creo que va a ser interesante para la comunidad también ver todo lo que estáis haciendo. Y esto de la familia que comentabas, sobre todo, que como comentabas, es una oportunidad para los desarrolladores de aquí de España que estén
Sí.
interesados en temas de blockchain Solana específicamente, porque les daréis soporte de todo tipo
Sí.
y esto siempre es muy, muy importante, ¿no?
Sí, sobre todo si tienes algún proyecto que estés ideando o algo por el estilo, la familia es como el lugar para ti para conectar también a lo mejor con partes que se estén faltando, si te hacen falta a lo mejor desarrolladores, si necesitas a lo mejor alguien de marketing. La idea de la familia es justamente impulsar talento español en esta blockchain de Solana. Solana tiene algo súper interesante que se conoce como los hackatones, donde la gente participa con un proyecto por la oportunidad pues, de ganarse premios monetarios, pero lo más interesante realmente es la oportunidad de que ese proyecto consiga funding pues, para volverse realidad. Y parte de lo que nosotros queremos es que siempre haya muchos proyectos españoles participando en los hackatones para que Solana se dé cuenta de que aquí hay talento, de que aquí hay oportunidades y siga pues invirtiendo justamente en esos proyectos y que la gente de aquí tenga la oportunidad de dar a conocer sus ideas.
Muy bien, muy bien. Estaremos atentos también a los
Sí.
eventos que la familia vaya organizando, que creo que por ahí hay bastantes ideas. Y bueno, nada, gracias. Yo te digo, muchas gracias, Dayana, por haber estado aquí con nosotros. Ha sido una charla muy interesante y animo de nuevo a todo el público realmente o a los que veáis este vídeo luego una vez esté grabado, que asistáis a estos workshops porque, ya digo, o sea, es que son gratis y la profesora
Sí.
es magnífica, así que
Gracias.
no hay más que decir, es la verdad, es la verdad. Se aprende mucho, muy bien elaborados, muy bien estructurados, en español encima, si no tenéis que lidiar con el inglés, si eso es un problema. O sea que no hay más que decir. Muchas gracias, Dayana.
Gracias a ti por
bueno,
invitarme.
nos veremos en la próxima. Y a todos los demás, pues hasta aquí hemos llegado. Nos veremos en el próximo Meetup. Hasta luego. Adiós,
Chao,
adiós.
chao.